In this video, we introduce the Probabilistic Trend Family, or PTF, modeling framework. But the purpose of this modeling framework is to measure the trends in 3 time directions: development, accident, and calendar. We will also want to quantify the volatility around those trends. And by doing those 2 things, we're able to relate all the data in the triangle. That triangle can be paid losses, case reserves, incurred losses, number of claims reported, anything that can be entered in a triangle. Once we have quantified the trends and the volatility, we will need to verify and validate the model assumptions that we're making to verify that the model is indeed describing the data in the triangle. Having described the historical data, we will then need full control over future forecast assumptions. So that's future to calendar year trends, development year trends, accident year trends, as well as the volatility in the process, so the underlying data, and any parameter estimates. When we have all of that, then we can actually project distributions by cell, accident year totals, calendar year totals, and total reserves, as well as pricing periods. So the purpose of PTF then is to really understand the features of your data and then provide critical insight to management about the trends, the volatility that's actually in the data that you're writing. So let's take a step back and actually look at the origin of where trends actually arrive when we're looking at a data triangle. So here we're looking at data from 1977 through to 1985, about 9 years worth of data. And we can see we've organized it by accident year and development years. And we've displayed it this way. So that means as we step through time, what we're going to do is add an extra diagonal to the output as data comes through. So when the next year comes in, 1986 in this instance, and then we get the next year's diagonal. So those blue cells coming in the triangle. And similarly, when we add the following year of data, 1987, again, we get another diagonal coming through, and you'll see each time we're adding a new accident year, we're adding a new development period on the right hand side of the triangle, and another cell on each step in between. So what that means is that when we're looking at adding parameters, you can see that if we're stepping to the right and then we add the next diagonal, then we're getting the ability to measure trend changes there, new development trends, so between 9 and 10. And similarly, when we step forward down the accident direction, then we can potentially add a new parameter between 1986 and 1987. Of course, in both those instances, there's only a few observations, and I've highlighted 3, that we're actually using to estimate those parameters. All right, so you'd expect a lot of uncertainty there. When you're stepping along the diagonal, so here we're adding those 2 diagonals, then we've actually got 21 observations. So 10 in 1986 and 11 in 1987. And that enables us to estimate the changes along the diagonal using the calendar year trends basically to estimate those. So when we're building the whole PTF model, we're putting together a combination of trends in the development years, down the accident years, and then along the calendar year diagonal. And although I'm saying years, in actual fact, it doesn't have to be. It could be quarters, months, half years, or some combination of the 2, where as long as your development columns are less granular, or the same or less granular as your rows. So for instance, you could have year versus quarter, year versus month. And this understanding of the data in a way that it arrives in time means that we can make some observation with respect to the modeling frameworks that we need to actually measure and understand what's going on in the data. So we really need a modeling framework that can model development trend changes. We'd expect that, especially going to the right of the triangle. We need to be able to model accident year trend changes. So going down the triangle, if there's a change in volume or change in mix of risk or something like that, then we need to be able to quantify and adjust for those changes in the data. But equally as importantly, we need to be able to measure trend changes along the calendar year direction, along the diagonal. So from previous videos, we have seen the link ratio techniques and the regression formulation, i.e. the extended link ratio family modeling framework, can describe those first two things of modeling development trends and accident trends, but it can't capture changes in the calendar year direction. So the probabilistic trend family enables us to identify trends in the three directions: development, accident, and calendar. And it also enables us to quantify the randomness, the volatility around those trends. So the next thing that we're going to do is we're going to look at an example M3IR5, where we've actually generated data which has one development year parameter, one accident year parameter, and 3 calendar year parameters. And what we will do is use the PTF modeling framework to determine whether it can identify those trend changes that we've actually used to generate the data, whether it can identify those successfully. See you in the next video.